Greetings, my new physics, backyard physics, or you might be in How Things Work lab for this is, I'm recording this, I'll probably use it for subsequent semesters, but I'm recording this in August of 2020, and we're going to look at, I'm going to play two people. One person is from the United States and one person is from Nigeria, which I just set up, and we're going to see how they would measure. They each have their own tape measures. We're going to see how they would measure this table that's here in our like TV room basement. Okay, my wife's gone right now running some quick errands, so I'm going to try and get it. If she's like, "You're doing what? You're filming in our house? Are you nuts? It's a mess." Well, anyway, she'll get over it. All right, so now here's what can happen. All right, here we go. Here's the table we're going to measure, and I'll get down on your level here in a minute. Now, what did I do with that tape? I just went and got a tape. Here it is. So, here's the deal. Your friend, you have a tape measure from the United States. Okay, so we need to measure the length of this table to make sure that it's what you want. So we're going to measure it. So you measure it, and you go, easy peasy. 44. You call out to him, you say 44, and he goes, 44? That seems pretty long for 44. Let me measure it. So he comes over, and he measures it, and he goes, it's not 44, it's 110. You say, what? He goes, yeah, there's 110. Actually, let me tell you exactly what he would have said. So I measured 44, right? Let me get out my quick and dirty calculator. I was trying to do the calculation in my head. I should have planned this out maybe, but I didn't. All right, so anyway, what were we doing? Oh, calculator. Calculator. Here we go. All right, so we go, all right. Yeah, 112, he would have said. What did I say? I said something pretty close to that. Yeah, your friend goes 112. You go, well, Nimrod, it's 44 inches. He goes, well, Nimrod, right back to you. You didn't tell me you were doing it in inches. So you got to know your units. You got to know anytime you take a measurement. I remember when I was in, you see the little story in the thing about when I was in Kuwait years and years ago and got, and saw the bank sign said 41 degrees or something like that. Not really. Or if you're traveling in a country other than the United States, where most people use kilometers per hour and things like that, which kilometers per hour is pretty easy if you're used to miles per hour. You see 40 kilometers per hour, and you can that'd be in a neighborhood. You think, well, that's kind of fast until you think about it. You go, oh, wait a minute. If I have that and add 10%, which is basically what you do to convert from kilometers per hour to miles per hour, because a mile is basically 60% of a kilometer. So if you take 60% of 40, you get 24. And so you go, oh, 24 miles. Well, that makes sense in a neighborhood. You know, what would kill me when I was in Okinawa 30 years ago or so is, and then again about 20 years ago. Really liked Okinawa, but anyway, you would get you'd see things for 10 kilometers an hour, and you go 6 miles. I don't even think my car will go 6 miles an hour without coming to a stop. You know, that's pretty hard to and that was in parking lots and stuff. That was kind of ignored. But anyway, so that's the idea behind taking an accurate measurement. That's one of the biggest things we do in science, and you're going to do in some of your labs here. And I've had a huge breakthrough, and we're going to have fun this semester. I'm telling you, I'm excited about it.